Hi folks, we are once again back with this exercise 6.5. As I told you, it's a Leibniz exercise. It's not going to get over in the near future. So many problems there and all important from the exam point of view. So we're just going to check the next problem. In the previous video, we did the problems 13 and 14. So now we are going to take this 15th problem. In this 15th, I could read it out from the textbook. In the 15th problem, it says, find the two positive integers find the two positive numbers x and y such that their sum is 35. It's there on the board. The sum is 35 and the product x squared y raised to 5 is a maximum. So it's like these 3-4 problems, they're very identical. The line of approach and the way of solving is exactly the same, and it's very simple also. Once you get the idea, it's quite simple to do. So but anyhow, we'll be going through that. This is their 15th problem where they tell you that x plus y is 35 and they give you the product x squared y raised to 5. Now it's always judicious to make a substitution into that variable which has got a lower power, because that way the solving becomes easy. So actually we should be substituting for x, because whatever has got the lower power, it's always better to substitute there, because your working is much simplified that way. Otherwise the working becomes a little more complicated. So as we know right from before, that product is a function whose maximum or minimum has to be determined, but it is working with two variables. So it's very difficult to work with two variables. We have got to reduce it to one variable, and we're going to reduce it to one variable by the given, whatever is given to us, that is going to help us to reduce it to one variable. So we have already, it's been given to us that x plus y is 35, which means that I told you we'll be substituting x because x has got a lower power. It's always better. Of course, both ways it's true. It's correct. You can get the answer in both ways, but why do extra work? This way the work is lesser. So the product, as we said, is x squared y raised to 5. X, let's substitute. 35 minus y the whole square times y raised to 5. If we were to expand this, it would come to 35 square is 1225, if I'm not mistaken. But it's always good to check it. 35 times 35, 5 5s are 25, 15, 17, 15, 9 and 1, 10. Yeah, 1225. I did have an intuition that it should be 1225, but then it was better to get it checked. So it's 1225, 35 square. So let's write this. 1225 minus 70y plus y square times y raised to 5. When we could expand it, it would come to 1225 y raised to 5 minus 70 y raised to 6 plus y raised to 7. So this is our expansion. You could keep it as a product and do it. That way also you could do. You could keep it as a product and then go in for the derivative and all that. That way also we can do. Now we all know very well that for maxima and minima, we have to get the first derivative, second derivative and so on. So let's continue with the journey of getting the first derivative, dp over dy, because we are working with y. So the first derivative is 1225 times 5 times y raised to 4. No need to multiply. You can also multiply. If you don't multiply, it's fine. Like you can get it simplified later. 70 times 6 is going to be 420 y raised to 5, and this is going to be 77 y raised to 6 when we take the derivative. So that's the first derivative. We also need the second derivative. So let's find the second derivative. It's going to be 1225 times 5 times 4 y raised to 3 minus 420 times 5 is 2100 y raised to 4 plus 42 times y raised to 5. That's our second derivative, and so it is only for us to verify at that stage. So obviously our next step is to get the critical point, dp over dy equal to 0, which is 1225 times 5 y raised to 4 minus 420 y raised to 5 plus 7 y raised to 6 equal to 0. Now it is practically impossible to work with this big expression. So obviously we need to do some kind of factorizing. So if we carefully look over here, 7 y raised to 4 looks common. It appears common. So let's take that common number out. 7 y raised to 4. So over here, since we know this is 35 times 35, if you can use our common sense, no need to multiply, get the answer. So we have a 7 to go out. So 7 times 5, this 7 has gone out. All other terms are there. So we are left with 35 one of the 7 has gone, 35, 5, 5. 135, another 5 and another 5 is left. Y raised to 4 has gone out. Of course you can expand and write, but I'm not going for all that. Here also 7 has gone, so 60 is left. So it's like 60y because y raised to 4 has gone out, and here you have y squared left. So these two product is 0. When you know that two products are 0, either one has to be 0. So then in that case, it could be possible that 7y raised to 4 is 0, or maybe like y squared minus 60y plus 35 times 5 times 5, that is 35 times 25. Let's find that out. I think it's high time we find it out. Equal to 0. Let me find this. 35 times 25. 25 times 5 is 125, and 25 times 3 is 75. So if we were to work 7, 875. I hope it's correct. 5, 7, 875. All right. So 875 is 0. Obviously, we have to solve this quadratic. Either you go in for the quadratic formula, or you go for the splitting middle term and go about it. See, our factor itself has given us the answer. 35, 25 we multiply to get 875, and 35, 25 can add up to give you 60. So there itself. Y equal to, this means that y equal to 0 is not acceptable. You don't get a 0 number, isn't it? It's not acceptable. So therefore, y squared minus 60y plus 875 equal to 0 is considered. Yeah. And then we move across. As I told you, we could split it as 35y and minus 25y plus 875, which will give you y times y minus 35, and minus 25 times y minus 35 is 0. Our factors are y minus 35, y minus 25 equal to 0, which will give us the y values as 25 and 35. Now, generally, when we get these values, always one value is a trouble. You generally go on with just one value. Both the values don't work. Here also, both the values are not going to work. Like, for example, 35 cannot work, because if y is 35, then x is 0. So, if y is 35, then x is 0. So, we don't accept the 0 values and all that. Now, we want a proper value. So, that is why, again, we don't take y as 35. Therefore, y equal to 25 is considered. That's our value. So if y is 25, then what is x? Therefore x is 10, because 35, x plus y is 35. So that way. So it's 35 minus 25, 10. So this is actually our value. But our work doesn't stop here, because we have not confirmed whether it is a maximum or a minimum. So let's do that also. It's like, therefore we have t squared p by dy squared as yeah, it's 1225 times 20 y raised to 4. For y for us is 35 raised to 4. So 35 raised to 4 first term, then 35 raised to 3 is the first term, then second term is 2135 raised to 4, and the last term is 42 times 35 raised to 5. Okay, so at least 35 raised to 3, let me take out. Okay, then in that case, what am I left with? 1225 times 20 minus 2100 times 35, and 42 times 35 squared. So this is 1225. So if we could take this 1225, these two together, then it's going to be 1225 times 62 and 2100 times 35. So it's like 35 squared times 1225 times 62 minus 2100 times 35. So let's quickly check whether it's going to be positive or negative. So 1225 times 62. I hope it's correct after doing everything I want to do. Yeah, 1225 times 2 is going to be 10, 5, 4, 2, yeah, 2450, and then times 6 is going to be 33 carry over, 18, 21 to carry over, 12 and to 14 1 carry over, 7. So it's going to be 0, 5, 5, 6. 76,550. Okay, 76,550 minus. Let's take 35 times 21. 35 times 21, 21 or rather let's write 35, 570. So it's 53735. It is 735 and the two zeros. Okay, what are we? Why are we doing all this? Let's check what they say in 15. The product is a maximum. Oh, right. So, all substitutions 1225 times 20, then 2100 times 35 raised to 4, out of which 135 has gone out. Next it is 42, 35 raised to 2, and 1225, yeah, so it's 62. And the way it is 1225 times 20 and 1225 times 42, so it is 62. Yeah, 35 and then 700, 735 with the two zeros. Oh yes, it's a maximum, so we should be getting a negative. So that's my hunt. Anyhow, let's check how it goes. Um, oh, why did I take? Oh, no wonder. How could I do such a big blunder? Because our y value was 25. Somehow I have always taken y as 35, and where's my duster? Yeah, very sorry, wrong substitution. So let's make it all as 25, and then it'll be fine. Yeah, so that'll be 25 cube. These are 25s. And then we have a 25 here, we have a 25 here, and this is 25 square cube actually. Cube. Okay, this is much manageable. Okay, so then we have the 25 cube outside, and we have 25. So let's see how this will go. Yeah, so this small piece, it's 25. So this is now 25 cube. So 1225 times 20 times 25 cube, which has gone out. So it is 1225 times 20 left over here. And then we have 2100 times 25, and then we have 42 times 25 squared. Perfect. Now let's see how the working will go. This is 1225 times 20. It's going to be 5 twos are 10, 2 twos are 4 and 1 5, yeah, 2 4 5, 24,500. And then let's get this addition also there. This is 25 squared, which is 625. 625 times 42. So that could be, we could have more common, so it wouldn't be so lengthy. Anyhow, 5 twos are 10, 2 twos are 4 and 1 5, 12, and then you have 5 fours are 22, carry 8, 10, 1 carry 24 and 1 25. So therefore you have 0 5 2 6 2 to 26,250. So that's an addition. 26,250, that's an addition. And then we have this, that's okay, 25 times 21, that's better to do. 25 times 1 is 25, and 25 times 2 is 50. So you have 525, you have 5 subtraction 52500. Now this is very clear that it's going to be a number much higher, the 525 is going to be much higher, so you'll get a negative. Anyhow, let's check. It is 0, then this is 5, then this is 7, and this is 10, and this is 5. So it is 50, 570, 52500. Anyhow, this is going to be a negative answer. So obviously this is going to be less than 0, and that's how you have a maximum. So therefore, maxima occurs. And then let's conclude. They also tell us what is the find the positive integers. So therefore, the required numbers are 10 and 25. That's how we go about it, and that's our 15th problem. As soon as we finish the 15th one, we're going to the next video with the 16th problem. So let's meet in that video once again. Thank you.